We'll talk about test coverage analysis, or making sure that the software testing you're doing is sufficient to achieve the goals of your test and what you hope to accomplish with it. There are a couple different test coverage models out there, but first to understand that testing coverage is used to identify, are my tests accurate? Are we being comprehensive in the testing that we're doing? So test coverage is really used to identify test quality, not product quality. So with these models, structural and functional models, we're making sure that our tests are effective at achieving what we set out to do. So these test coverage is generally looking for aspects of a program that weren't tested, so things that got missed by the test cases. It will help identify additional test cases that need to be done to make the test comprehensive. It's looking for quantitative measures like, does the program do X, Y, or Z, yes or no? And it's looking to reduce the number of redundant test cases that you have to accomplish as part of your test plan. So you're optimizing around, if I've got 10 tests to do and 2 of them overlap, I can chop those one of those off and just have to do the 9 tests as opposed to 10. The structural test coverage model takes the approach that you're looking at the program against what the source code says it's doing. And you use this type of test model when you don't have any requirements to work from, meaning you've got an application and you're not really sure what it's supposed to do. All you have to go on is the source code. So you structure your source code around, well, the source code appears to be doing this, let's just see if it does that. Contrast that with functional testing, which is looking at the program from the perspective of, does it do what we wanted it to do? So whatever the requirements are, we're testing a program against those requirements. And you use this when you have those requirements. You don't always have that, in which case you fall back on structural test coverage model. But when you do have those requirements, you really want to test your program against it to make sure that it was designed and developed and does what you think it really should do. The analysis is really built around a couple different aspects, measures and conditions. Measures of effectiveness go towards understanding whether the program meets operational success. Simply put, does the program work? If that's the case, then I've met my measures of effectiveness for operational success. Measures of suitability says, does the program do what I want it to do? Does it accomplish the tasks that it needs to do and that it was designed to do? So from a reliability standpoint, availability standpoint, does the program work? There's almost a fine line between those two, but there are 2 different areas that you're using measures for test coverage to make sure that the program does what you want it to do. The last one here with condition coverage, you're using to identify true-false outcomes. The program displays X, yes or no. The program does not crash, yes or no. Those are condition coverage tests that you can run through your test coverage analysis. The test coverage output, you really want to make sure that your test has adequate criteria defined for how it's going to report the results of the test. So you want to upfront agree on what the rating criteria are and the definitions. So if you have a scale of program success on a scale of 1 to 5, what does a 1 mean? What does a 5 mean? What do each of the levels in that mean? And what does the program have to do to achieve each of those levels? Frequently when you're doing software testing, you're dealing with multiple organizations. You have the developers, you have the acceptance, you have quality assurance, you have the business operations side who may be the consumers of this application when it's done. And they all have competing priorities. So the only way to adjudicate between all those different stakeholders is to come up with a common set of criteria for defining what the test looks like. And that's the only way that you're going to stay out of trouble when you do this test and avoid upsetting one group or the other or somebody claiming that the test was unfairly stacked in somebody else's favor. So the output here, you should determine what test outputs are relevant. You may determine from your test coverage plan that you need additional tests that have to be conducted. And then you should define some type of record for how you're capturing the data as part of this test. What does the output look like? And how are we going to compare that to what we expect it to be? Is that all going to be automated? Is there going to be somebody looking at test output versus program requirements and going, yep, okay, it's all the same? And it can also help you determine the priority of fixes. Because as part of your test output, you might realize that certain things are more broken than others, or this is a critical function that's got to work and there's a bug in it, we got to prioritize that fix over it. So your testing might focus on that first before doing other things. There are different types of output that your test might create. Of course, you might log your output to a database. You might generate a set of scripts that will go and do additional testing for you based on what you're finding in the output. You might end up with all of this data in a log file. You might consider physical effects as well, physical measurements like temperature, weight, or electrical characteristics if you're testing a system as opposed to a software application. And then the last part of output that you might see here are feedback, actual written qualitative input like feedback or user surveys or comments based on what the testers interacting with the program actually see. There are a couple different code or test coverage tools that you can use. Again, these are not going to necessarily do the test for you. They're going to help you define what the test should look like. Actually, a lot of these tools will define what the test looks like and then branch into helping you do the test as well. But what we find is that all of these programs, they're going to be applicable to you in different situations. So look at the test that you want to run, understand the environment that you have to do the test in, and select the appropriate tool. For example, Parasoft's code coverage analysis will look at individual lines in the code and determine whether the coverage, the test coverage, is going to hit that block of code, or that line of code, or that path tree through the code. VectorCast does application analysis on airborne systems, so this is certified by appropriate regulations that it can do this. And then Semantics Designs is looking at arbitrary procedural languages like C, C++, Java, PHP, C#, etc., and looking for test coverage within those languages.